my name is Joe Royer. I'm the Vice President of R&D of GeoTree Solutions. We thought it would be really helpful to answer some of our frequently asked questions that we get at webinars or at lunch and learns or when we're out talking to customers about our products. So I'm going to have one of our colleagues, Emma, ask me some questions, and we will do our best to answer them here in a series of videos. In this video today, we're going to talk about the benefits of GeoSpray geopolymer.
Why doesn't GeoSpray mortar form cold joints?
So first, we should probably discuss what a cold joint is. So a cold joint happens in Portland cement materials or in cement materials in general when you've poured one layer of material, you let it cure a day, it hardens, you come back and pour the second layer on top. There's no reason for those materials to bond. The reason goes back to the chemistry, and that regular cement has a mechanism where it takes up water, and that's called hydration. And the water hydration system basically means that when you pour a second layer, it doesn't really care what's happening up there. It's just not going to react with it. Geopolymers are very different because they are a living chemical reaction. And what ends up happening is we end up pouring the second layer, and now you get reaction through the joint so that the materials are monolithic because they're a living reaction, and they don't know the material sitting on the surface isn't part of the reaction mixture that you made up. They'll react straight through, and you won't get a cold joint, you'll get a monolithic material. And we've done a lot of testing to show that.
Why are geopolymers beneficial when exposed to sanitary sewer corrosion conditions?
So in a sanitary sewer, you have sewage flowing through the pipe. In that sewage, there will be things called sulfates. There will be microbes in the sewage that will dissolve or digest the sulfates, turn them into H2S. So you'll often hear in this industry H2S or sulfuric. H2S corrosion is a term you'll hear a lot. What ends up really happening is that gas comes out of the sewage, it gets to the crown of the pipe, and there are another set of microbes there that turn it into sulfuric acid. That reacts with something called calcium hydroxide that's in cement materials, and it turns it into gypsum. It becomes water soluble, and your pipe slowly corrodes. So GeoSpray has very small amounts of calcium hydroxide, probably 1/10 of that that's in regular Portland cement. And second of all, so that mechanism is greatly reduced. The next mechanism of corrosion is that acid has to actually break covalent bonds, and geopolymers, specifically GeoSpray, have a lot more covalent bonds to break, so it's just harder to do. So they have better resistance than normal cementitious materials, which makes them very beneficial in aggressive sanitary sewer conditions.
What does the higher flexural strength of GeoSpray mean in practical terms in project design?
So first we should talk about flexural strength in general. So flexural strength of a cementitious material is usually measured by a large beam where you apply a load and then it cracks, versus a plastic material, if you're familiar with CIPPs, where they take a small beam and it flexes, but it doesn't really crack. So we're measuring the same thing, which is what's its resistance to flexing, but the flexural strength is actually the maximum value prior to it cracking. And it has a geometric factor in there. So you measure a load and calculate the strength in typically a pressure unit like PSI or MPa. There are multiple ways to measure it. The first, we generally recommend anybody would, from an engineering perspective, would want to use a conservative method. The most conservative way to measure this is what I would call, from a plastic standpoint, I'd call it a 4-point bend. From an ASTM cement standpoint, it's called third point loading. So you have 2 points on the bottom and 2 points on the top. So it's a 4-point system. You push the top down, across the bottom, and it cracks. That is ASTM C78 or methods like it. ASTM C293 is called a 3-point bend or center point loading, where you have 2 points at the bottom, 1 point in the top at the center, and you apply that load again from the top and it breaks. You will always get a higher value from the center point or C293 test than you will for the C78 4-point / 3rd point loading. And in that case, we would recommend you use the more conservative lower value in your design. GeoSpray, geopolymer, has a lot of benefits, one of them being the high flex strength that comes from the chemistry and the other materials and the design of the system. And maximizing that is one of the key formulation criteria for our material. When you maximize that, what it really means is you can carry more load while it's being flexed, which means that you can put in, for the same amount of load, you can put in a thinner lining, which maximizes your hydraulic capacity, gets you a better structure, is a lower cost, more efficient way to do it. The lower the flexural strength, the thicker that lining has to be, the less area you have for flow, the lower the hydraulic capacity, and the cost of using that material is generally higher because you have to put more of it in. Hopefully this video has been instructive. If you have any questions, feel free to contact us at our website or our email, which will be on the screen, or contact any of your representatives from GeoTree Solutions. Thanks for listening.